Hello and welcome to this session. LO1. Understand software design and development approaches. Today, we will explore how software evolves from an idea into a fully functional product, looking at the key approaches, tools, and methodologies that shape the software development process. This unit builds on basic programming skills and introduces professional practices in software engineering. It focuses on coding techniques and design approaches. Modern industry practices and popular tools are also covered. The goal is to bring code into production in an agile manner. Learners will understand the full software lifecycle. LO1 is about understanding how software is planned, designed, built, and tested. It goes beyond just writing code. You need to explain development approaches and design methods. Tools and techniques used during development are also essential. Different projects require different approaches. The software development lifecycle has several stages. It starts with requirements analysis to identify user needs. Design involves planning the system's structure, data, interface, and logic. Implementation is where the actual coding happens. Testing ensures the software meets requirements. Waterfall is a linear approach where each stage is completed before the next starts. It has a clear structure and is easy to manage. It works well for small projects with stable requirements. However, it is hard to make changes later. Late testing can reveal expensive problems. Agile is an iterative approach with regular feedback. It is flexible and handles changing requirements well. Frequent testing and feedback are integral. It requires strong communication and can be harder to manage. It suits projects where requirements may change. Spiral combines design and prototyping in repeated cycles. It focuses on risk management and suits large, complex projects. However, it is more expensive and harder to manage. It is best for high-risk systems. It allows for early identification of risks. Rapid application development focuses on quick development using prototypes and user feedback. It delivers fast results and involves strong user involvement. However, it can lead to weak structure if rushed. It is not ideal for very large systems. It suits small to medium projects with tight deadlines. Procedural design breaks a program into functions. It is good for simpler programs with clear logic. Object-oriented design uses objects and classes for real-world modeling. Modular design breaks software into components for easier testing. Each approach suits different types of projects. Design tools include algorithms, pseudocode, and flowcharts, UML diagrams, model system, structure, and behavior. Wireframes and storyboards plan user interfaces. Structure charts show module relationships. These tools help in planning and visualizing software design. Imperative programming uses step-by-step instructions. Object-oriented programming focuses on objects and classes. Event-driven programming is controlled by events. Declarative programming focuses on desired outcomes. Each paradigm influences system design and code organization. Different projects need different approaches. A banking system may suit waterfall for strict requirements. A mobile app startup may suit agile for evolving needs. A high-risk engineering system may suit spiral for risk analysis. Judgment is key in selecting the right approach. Choosing the right data structures and algorithms is crucial. It affects software speed, memory use, and maintainability. Different problems need different combinations. For fast lookup by key, use hash tables. For hierarchical data, use trees. Searching algorithms find target items in datasets. Linear search checks items one by one. Binary search divides a sorted list in half. Sorting algorithms arrange data in order. Bubble sort is simple but slow, while quicksort is faster. Critical sections involve code that accesses shared data. Race conditions occur when threads access shared data simultaneously. They can cause errors and inconsistent behavior. Solutions include locks and synchronization methods. Proper control ensures reliable software. Big O notation describes algorithm performance as data grows. Constant time is efficient, while linear time increases with data size. Quadratic time becomes inefficient quickly. Logarithmic time is efficient for large datasets. Understanding Big O helps in choosing efficient solutions. Choosing the right combination is key to solving problems. Use hash tables for quick student record lookup. Use merge sort for sorting exam scores. Use trees for hierarchical course structures. Protect shared booking systems with synchronization. Design patterns are reusable solutions to common problems. Creational patterns manage object creation. Structural patterns organize object relationships. Behavioral patterns manage object interactions. Patterns improve code reusability and maintainability. Test-driven development is a disciplined approach where tests are written before code. It uses the red-green refactor cycle. TDD relies on unit testing and automation. It reduces defects and improves code quality. It encourages better software design. This is the conclusion of the video. Software design and development require structured approaches and tools. Understanding life cycles, design patterns, and testing methods is crucial. By applying these principles, you can create efficient and reliable software. The right methods lead to better outcomes. Master these skills to excel in software engineering. Feel free to get in touch on WhatsApp at 0748436168 if you have any questions. Thank you for being here today, and we'll see you at the next session.